Hello guys, welcome to Civil Concept, and in this video we will see the bar bending schedule of cranked reinforced slab. Okay, so cranked reinforced slab is like you can see in this slab the reinforcement has bent like this. Okay, so this is known as crank, and this types of reinforcement is provided in the two-way slab. Okay, it is also provided in one-way slab, but there is only in one direction like this crank bar. Okay, so let's start our video. So first of all, let us see bar bending schedule helps to estimate the quantity of rebar required in the structure. Okay, so why should we do bar bending schedule of any structure? We have to know the estimate of the quantity of the rebar required in a structure. Okay, so here we will see bar bending schedule of two-way slab. Okay, so there are given some points given for this slab to estimate to calculate the bar bending schedule of this slab. So first of all, in number 1, two-way slab, the size of slab is 8080 by 6080 by 150, which is the length, width and depth of the slab. Okay, and killer cover is how much? 40 mm. Okay, in the side of this slab the killer cover is how much? 40 mm. Okay, now the effective length and width of rod will be how much? 8000 by 6000 by 150, which is also equals to 26 feet by 19.5 feet by 6 inch. Okay, if we convert it into feet and inch, then we will get these types of measurement. Okay, so what is effective length? Here effective length is, for example, this is our slab, and if we subtract clear cover from this slab, then we will get what? The length of this rod. Okay, so after subtracting the clear cover, we will get this much the dimension in mm. Okay, so you can also calculate in mm, or also you can calculate in feet and inch. Okay, so here all calculation will be in mm, and we will calculate all the dimension in mm as a center to center distance, as well as this length and width of this slab. Okay, so in number 2, main bars is given up to 12 mm, and its center to center distance is how much? 100 center to center distance 100 mm, which is also 4 inch. Okay, so this is our main bars, and main bars are provided in a shorter span of the slab. Okay, so here the center to center spacing is how much? 4 inch. Okay, now let us see in number 2, for distribution bars 12 mm of bars have been used, and center to center spacing is 150 mm, which is also called 6 inches. Okay, in number 4, the development length has provided in the slab, which is LD is equals to 40D. Okay guys, so D is the diameter of the rebar. Okay, so D is here given 12 mm, 10 mm, whatever it be. So D is the diameter of the rebar. If there is development 40D, then 40D means 40 into diameter. If you are using diameter of 10 mm, then it will be how much? 400 mm as a development length of this slab. Okay, so again we provide what? Top extra bar, and which is of 8 mm, and center to center spacing is 150 mm in both direction. First of all, I would like to show you where these extra bars are provided. For example, we have provided crank bar like this in the slab. Okay, and in this direction also we have provided crank like this in this direction. Okay, so in L by 4 distance from this side, L by 4 distance, and from this side L by 4 distance, we have to provide top extra bar like straight bars. Okay, in this direction also we have to provide up to this L by 4 length. Okay, so this is our top extra bar, which is of what? 8 mm, and center to center spacing is 150 mm, which is also 6 inches. Okay, so you can convert all the dimension in feet, inch, or you can convert all the dimension in mm. Okay, now let us move toward our calculation. Okay, so calculation of the bar bending schedule of slab. Okay, so in number 1 we will do step by step calculation. So in number 1 we can see number of main bars and distribution bars. We have to first of all calculate number of main bars and distribution bars. Okay, so number of main bars is how will we calculate? Just divide this length by its spacing plus 1. This is the formula. Okay, so 8000 is this length, because we have laid this main bars in this direction. Okay, so we have to take length of this direction and dividing by its spacing. The main bars spacing is how much? 4 inch, or 100 mm we have taken plus 1. This is the formula, and after calculating we will get how much? 81 number of main bars. Similarly, for number distribution bars, number of distribution bar will be what? Width, this width 6000 divided by its spacing, because we have to lead this distribution bars in this direction. So after dividing it by spacing and adding 1, we will get how much? 41 number of distribution bar. Okay, now in number 2, what we have to do? We have to calculate the cutting length of the main bars and distribution bars. In number 1, what we have to do? We have calculated number of main bars and distribution bar. Now we will calculate the length of main bars and distribution bar. Okay, so cutting length, the formula to calculate the cutting length will be this: clear span plus 2 into LD plus 1 into 0.42 D minus 45 degree bend into 2. Okay, so guys, this is a formula and we have to remember this, and this is a formula for crank bar. Okay, you can see here the rebar like this. This is known as what? Crank bars, and this is the formula to calculate the rebar length of rebar like this. Okay, so when we calculate the cutting length of the main bars, okay, so main bars will be in this direction. Okay, so in this direction, what we have to do? We have to take the span, which is 6000, okay, plus 2 into LD. LD is what? Development length. So we have previously discussed that development length should be what? 40D. Okay, so 40 into D is the diameter, which is 12. Okay, 12 mm we have used for the main bars, and plus 1 into 0.42 into D. Now guys, this is very important, how to calculate D and what is D. So D is what? You can see this is the thickness of our slab, and when we zoom it, I am zooming it, you can see here D is this distance. Okay, so this is our D from here to here only. Okay, so when we subtract this clear cover and this clear cover below this thickness of the slab, then we will get what's D. Okay, so this is our D. Okay, so we have done the same formula. D is equals to thickness. Okay, so this thickness minus 2 into clear cover, this clear cover, and minus 1 into diameter of the steel bars used in this slab. Okay, so D is equals to 150 mm, which is the thickness of the slab, and 2 into 25, which is the clear cover. 2 into 25 mm is the clear cover, upper clear cover and lower clear cover, and minus 1 into diameter is the diameter is 12 mm for this slab. Okay, and after calculating we will get how much? D is equals to 150 minus 50 minus 12, we will get how much? 88. Okay, so same thing I have written here, 88. Okay, so 88 minus 12 into 1, which is 45 degree bend. So for 45 degree bend we have to deduct 1D. Okay, so D is the diameter of the rebar, so 1D is equals to 1 into 12, which is again 12 into 2. Okay, so because we have two bend in this direction, okay, one bend and another bend, so we have to multiply it with 2. Okay, so after calculating we will get almost 6972.96 mm, and when we convert it into meter, then we will get almost 6.97 meter. Now in the same way, cutting length of the distribution bar, so in the same formula we have to use same formula, which is 8000 clear span, 8000 plus 2 into 40 for LD, it means 40D. Okay, plus 1 into 0.42D. in the same way I have written here, and again 45 degree bend into 2, 45 into 45 degree into 2, and after calculating we will get how much? 8972.96 mm, which is 8.97 meter, which is the cutting length of the distribution bars in this direction. Okay, so this is the distribution length of the main bars and distribution bars we have calculated. Now in number 3, what will we do? We have to calculate the top extra bars. Okay, so this is our top extra bars at the distance of L/4 and at distance of L/4. Okay, you can take also the distance as L/5 according to the design of the slab. Okay, now top extra bars. For top extra bar, number of long bars and short bar, we have to calculate number of short bars and long bars, and after that we will calculate the cutting length of the long bars and short bars. Okay, so to calculate the number of long bars and short bars, number of long bars will be 6000 divided by 5, which is L/5. Okay guys, we have to provide the steel bars up to length L by 5 only. Okay, so you can also put L by 4, L by 7 according to the design, but here I am taking L by 5 up to length L by 5, and again I am dividing it by 150 mm, okay, which is the center to center spacing of the top bars, okay, plus 1. And we, after calculating, we'll get how much? 9 numbers. And when we multiply it with 2, because we will provide in this direction also and this direction also, so after calculating we'll get how much? 18 numbers of long bars, and for short bars we'll get how much? 24 number of bars in this direction at the topmost part of the slab. Okay, now we will calculate the cutting length of the long bars and short bars. In the similar way, what will we do? We have to add this killer length, okay, so killer length, and after that we have to add development length. Okay, so when we provide steel bars in this direction, then we have to provide a bended part somewhat at the end of this bar, so this is known as development length, and we have to provide development length what? 2 into 40D, because we will provide development length in this direction also and this direction also, so we have to multiply it with 2, and development length will be 40D. Okay, so D is our diameter, and diameter is 8 mm, and 40 is our constant. After calculating, we will get 8640 mm, and in meter we will get how much? 8.64 meter. In the similar way, cutting length of short bar, we will add this killer span plus 2 into 40D, which is the development length again, and we will get how much? 6640 mm, and when we convert it into meter, then we will get how much? 6.64 meter. Okay, so we have calculated all the length of main bar, distribution bar, and top extra bars, and short as well as long. Okay, now we will see the bar bending schedule table I have made here. Okay, so it is very clear and very easy. So here I have taken description, diameter of the bar, numbers, length, weight per meter, and quantity. Okay, so main bars diameter is how much? 12 mm, and number, how much number we have calculated in previous page? We have calculated 81 numbers of page main bars, and after that its length was how much? 6.97 length, and weight per meter length for 12 mm bars is how much? 0.89. okay, and when we multiply these bars, numbers, length, and weight per meter, then we will get how much? 502.46 kg of main bars, which is of 12 mm. okay, guys, you can also use this formula, D into D, which is diameter of the bars, into diameter into length, divided by 162.25. okay, so when we use this formula, then we have to do what? We have to multiply this 12 into 2 times. After that we have to multiply this length here, and this is our constant. We don't require this weight per meter. Okay, just use this formula. Then when we use this formula, then we will get here answer 501 point something 98 something. Okay, so this is similar like this, and something will be different. So similarly, for distribution bars, diameter of the bars has used 12 mm, and numbers is 41. We have calculated length was 8.97 meter, and again the weight per meter length will be 0.89, because we have used same 12 mm of the diameter. Okay, and again when we multiply all this, we will get what? 327.31. and also you can use this same formula to calculate this weight of distribution bars as well. And short extra bar, for short extra bar we will use 8 mm of bars, numbers will be 24. We have calculated length is 6.64, and weight per meter will be 0.4. okay, and when we again calculate all these, we will get 63.74 kg of short extra bar in short direction, and in long direction extra bar will be used of 8 mm, and number will be 18, length is 8.64, and weight per meter is 0.4 again, because we have used 8 mm bars. And again when we calculate, we will get how much? 62.21. okay, and after adding all these, we will get what? 955.75 kg of steel bars we have used to construct these types of slab. Okay guys, so in this way we can calculate the total quantity of steel bars used in the slab, which is of crank. Okay, so I have written here all the bar bending schedule, and you can use this formula as well, or simply we can multiply all this value to get the answer. Okay guys, so this much for today. Please like this video and subscribe my channel for new update about civil engineering. Thank you.